So question number 9 is asking us to find the domain and range of the two composite functions. So first we have f of g of x, and obviously when you substitute in g of x to f of x, the square root and the squared cancel out, and it gives you 3x minus 6. It is tempting just to say that the domain and range are all real numbers since it's a line, but remember we have to go with the restrictions of the original function. And since this g of x function has a lot of restrictions, you can see it here in blue, basically it's always going to be positive. You're never going to get a negative output from g of x. So when we plug in g of x to f of x, we get this green graph here. And from here it's obvious that your domain has to be greater than or equal to 2, and then we see that from our original domain restriction with g of x. F of x is not bringing in any domain restriction, but since it is squaring everything, and since there's no way to get a negative output from g of x, all your y values are going to be positive. Now, if we move into g of f of x, which is the second part of this question, this one makes a little more sense. It ends up being the square root of 3x squared minus 2, and you can see the graph here. It's pretty obvious where the domain restriction is coming in here. It's just from taking the part under the radical here and then making sure that that is greater than or equal to 0. You get your restrictions, radical 6 over 3, plus or minus radical 6 over 3, and then it can be greater than the positive or less than the negative. And then once again, since this is a square root, it's going to be impossible to have any negative outputs, so your y values all have to be greater than 0 or equal to 0.